address. And then, of course, we have to do a from account. Then we'll wait for this transaction to complete. And if we've done this right, we should have borrowed some DAI programmatically from the Aave protocol. So let's even print, we borrowed some DAI. And we can once again call our getBorrowableData function, since this getBorrowableData function will print out our new account information for how much we borrowed. So let's go ahead and run this on mainnet fork again. Awesome. So if we've done this correctly, we now see that we've borrowed some DAI. So we can see here, we now have 0.1 worth of ETH deposited, 0.059999 worth of ETH borrowed, and we can borrow a little bit more worth of ETH. This 0.75999 is actually the DAI that we've borrowed. So we've deposited some ETH and we've borrowed some DAI, and Aave is telling us how much that DAI converted to ETH is there. So we actually borrowed 160 DAI, which is great. All right, we've now learned how to borrow everything, which is fantastic. Let's go ahead and actually repay that back. So we're going to call their repay function. And let's just put this into its own function called repay all. And we'll give it the amount that we want to repay, the lending pool address, and our account. So let's define repay all, where we're just going to repay everything that we have. And again, we're going to add an amount, lending pool, and account for parameters. So if we're going to pay back this network, first thing that we need to do is actually call the approve function and approve that we're going to pay back. So the first thing we're going to have to do, per usual, is we're going to actually have to approve that ERC20. So let's say how much we're going to approve, web3.2way amount ether to the lending pool, and we'll grab it from the config, networks, network.show active. And this is going to be the DAI token again. And of course, with our account. I believe our approve ERC20 already calls wait, so we don't have to call it here. So once we approve, we're going to be using this DAI that we borrowed to pay most of what we have borrowed back. Now we're going to call the repay function. So we'll say repay tx equals lendingpool.repay. First, we need the asset that we're going to use to repay, which we're going to use config, networks, network.show active, DAI token, the amount, which is going to be passed in here, amount, the rate mode, which we've hard coded to 1, and the address on behalf of, which is going to be account.address. And then, of course, we always have to do from account. Then we're going to do repay tx.wait. We're going to wait 1 block confirmation, and then we'll print repaid. Whew. And if we've done all this right, we'll do 1 more print line saying you just deposited, borrowed, and repaid with Aave, Brownie, and Chainlink. Whew. All right, moment of truth. Let's see if this works. Whew, we did it. Repaid. You just deposited, borrowed, and repaid with Aave, Brownie, and Chainlink. Awesome work. Now, if you want to, what we can also do is we can see if this will work with our wallet address here. So what I can do is I can copy my address, go to Cove and Etherscan, and paste it in here. And right now we can see that I have a whole bunch of link and some ether. What I can do is actually test everything that we just ran through on the Coven testnet and see everything happen right on this Etherscan address. So if we've been following along correctly and we've added contract addresses appropriately, we should be able to run the exact same script on the Coven testnet. I'm going to do one additional thing here, though. I'm going to have us not repay so we can see us with a little bit of debt. So let's go ahead and run Brownie, run scripts, Ave bar to pi, and we'll change to network Coven. And now it's going to take a lot longer, as we've seen before, because we're actually making these transactions on a real network. Whoops, it looks like I got one of the die F price feeds wrong for Coven. So I can once again just go over to the documentation, die F, and it looks like this is the real address for Coven. So we'll copy that, paste it in here. Whoops. We should also probably have some weth token. So first, let's go ahead and run our get weth script for Coven. And we're going to change this account to get account. Brownie, run scripts, get weth.py, network Coven from our helpful scripts. That way we can actually use our wallets correctly. All right, great. So now we have 0.1 weth. And actually, again, what we can do is grab this address here, add token, paste it in, add tokens for the weth token. And now we can see we have 0.1 weth, which is perfect. So now that we have some weth, we can run the borrow script. Ave Brownie run scripts, Ave borrow, network, Coven. And wow, we can see that everything went through correctly and successfully. So since I actually commented out this repay function, we still should have die in our address here, in our wallet here. And again, we can see that by going to our Brownie config, grabbing this die token address, add token, custom tokens, next, add tokens. And we can see we do indeed have 160 die in our wallet. We have no weth since it'll be an Ave now, and we have borrowed die instead. You can also see that we now have this aweth if we added it from when we were working with the UI. We have this interest-bearing weth instead of regular wrapped Ethereum. Let's look at one of these transactions. We can see that our borrow transaction gave us some stable debt bearing die and also some die. So we owe Aave some die from this debt. We got some debt, we got some die, and we gave out some Aave interest-bearing die to the rest of the Aave protocol. You'll notice now, if we go to testnet.aave.com-dashboard, we'll see exactly what our script just did. We have 160 die borrowed, and we have 0.1 ETH deposited. If we want to repay our funds, we can do it with our current collateral or from our wallet balance. And you'll notice something. If I try to repay everything from my wallet, all the DAI that I've actually borrowed, you'll notice we don't have enough funds to repay the full amount. This is because since we actually borrowed a little bit, we've accrued some of that interest. So we actually owe more back than we originally borrowed. That's how the loans work. So when you're designing this repay functions, be sure to have that in mind. You can also have your repay be -1 to repay the entire debt. It's recommended to send an amount slightly higher than the current amount borrowed. But in any case, maybe we say we want to do from our current wallet, we'll hit max, but maybe we want to actually just repay with our current collateral. We can go ahead and repay the maximum amount. Again, we could do this all from the UI. We'll approve. And this is exactly what our repay function actually did. And now we're all repaid up. If we go back to our dashboard and we hit refresh, we'll see we just have a tiny bit of Ethereum and no more borrowed assets. Awesome. You've essentially learned everything that we need to go through for here. This is a massive step forward in teaching you how to become quantitative DeFi wizards and build really robust applications and really robust financial applications in the DeFi world. Now, something I want to point out, even though this isn't a Python course and we're teaching more about Solidity and smart contracts, it's still in your best interest to test these functions. Yes, I know they're Python functions, but it's still going to be in your best interest to test them to make sure your application always works as you expect it to. Now, I'm not going to go through this testing suite that I put here, but it's a really simple testing suite to test some of the different functions that we created. It can be really helpful, especially for something like get asset price, where the math might be a little bit off and you want to make sure it's correctly. Again, link in the description to seeing some of these tests. This is actually going to be even easier than that lottery contract that we did, since we're just testing Python functions. And again, you can test these all with Brownie Test. All right, you are all doing fantastically. Now is another fantastic time to take a break, go for a walk, get some food, because our next session, our next lesson, we're going to be learning about NFTs, how to build them, use them, and deploy them. Look, NFTs are hot right now. NFTs, also known as ERC 721s, are a token standard that was created on the Ethereum platform. NFT stands for non-fungible token and is a token standard similar to the ERC20. Again, ERC20 is like Link, Aave, Maker, all those goodies that are found on the Ethereum chain. An NFT, or a non-fungible token, is a token that is non-fungible. This means that they are starkly unique from each other, and one token isn't interchangeable with any other token of its class. A good way to think about it is $1 is interchangeable with any other dollar. $1 is going to have the same value of another dollar. Those are fungible tokens. That's like ERC20s. One link is always going to be equivalent to one other link. By contrast is going to be NFTs. Those of you nerds out there would know, like a Pokemon would be a good example of an NFT. Your one Pokemon is going to have different stats, different move sets, and isn't interchangeable with any other Pokemon. Or maybe a more relatable one is like a trading card, a unique piece of art, or the like. So that's what these NFTs are. They are non-fungible, non